Hello, welcome to Unit 2, Lesson 2 on Functions and Graphs. I'm Professor Blackman. Today we're going to be talking about how to find values given a function using what is called function notation. It's given as f(x), and this is read as f of x. We're going to draw on graphs. And we're going to determine whether a graph is a function using the vertical line test. Remember, vertical lines are up and down. These are vertical lines. All right, so a function is a corresponding set, and we use it to find the domain. Domain is all the input values, which are typically your x values. And the second set of values we call the range, which is typically your y values. And then together, we have all of our domain and our range. It is very important in order to be a function that each domain goes to one and only one range. If values of x go to multiple y's, then it is not a function. And if it's not a function, we call it a relation. All right, let's go ahead and get started. So this is function notation. So what we are going to do is take any values that we have here, we plug in for x. So our x values go in here. So this is 0 to the third, which is 0. This is -1 to the third, which -1 times -1 times -1 is -1. This is 2 to the third, which is 8. This is 10 to the third. It's 10, add a 0, you get 1,000. And -5 to the third. Negative times negative times negative is negative. 5 times 5 times 5 is 125. And -3a to the third. Negative, negative, negative is -333. 27. A is a to the third. All right, so here we're going to take our values of x, plug into absolute value. Remember, for absolute value, it makes everything positive. So 0 becomes 0, so 0 plus 1 is 1. 1 plugged in is 1, 1 plus 1 is 2. -1 plugged in, absolute value of -1 is 1, so it's 1 plus 1. 2, -10 is plugged in, and that gives us 10 plus 1, which is 11. A minus 1, so this absolute value of a minus 1 plus 1. And then we're going to take our last one, plug that in, and we get a plus h plus 1. All right, let's go ahead and look at some more examples. All right, we are going to graph these. So what we are going to graph is we are going to look at this. We have two different ways that we can graph. One, we can graph using slope-intercept. So we identify using y equals mx plus b. So our m is -2. And our b is 3. So this means the slope is -2. And our b lets us know our y-intercept at 0, 3. This is our y-intercept. So let's put that on the graph. Our y-intercept is 3. And our slope is -2. So that's down 2 over 1, down 2 over 1. And we end up with this graph looking like that. Right? Now, if you don't know how to graph using slope-intercept, you can always graph using the table method. So you have x, f of x, which is y. So you pick some values. If you plug in -1, you get -2 times -1, which is 2, plus 3 gives you 5. Plug in 0, you get 0 plus 3. Plug in 1, you get -2 plus 3, which is 1. Plug in 2, you get -4 plus 3, which is -1. So 2, -1, right there. 1, 1, right there. 0, -3. 0, +3, right there. -1, 5, right there. So you can see all those points are on the graph. So either way you want to graph. So here, slope is 1/2, and our y-intercept is 0, 1. So put a slope point at 1. A slope of 1/2 means it goes up a half. Each time we increase 1, we're increasing a half. Or some people will use rise over run. So that means we rise 1, run 2. So rise 1, run 2, rise 1, run 2. And you end up with this graph. And again, you can also use the table method. So let's say, now since my fraction of my slope is 2, I'm going to increase by 2. Just because it makes it easier to plug in. Half of -2 is -1, gives me 0. 0 gives me 1. Half of 2 is 1. 1 plus 1 is 2. Half of 4 is 2. 2 plus 1 is 3. So 4, 3 right there. 2, 2 there. 0, 1 there. -2, 0. All right, let's go ahead and look at some more examples. All right, the previous slide were all examples of linear, so they all produced straight lines. These are examples of quadratics. And we know that because of the x squared we can see. Whenever you are graphing a quadratic, I always recommend building a table and using the values -2, -1, 0, 1, and 2. All right, so when we plug this in, -2 squared is 4, and the negative out in front makes it -4, plus 1 makes it -3. So that's -1 plus 1, which is 0. Plug in 0, you get 1. Plug in 1, you get -1 plus 1, which is 0. Plug in 2, you get -4 plus 1, which is -3. And so with these, we end up right here. If you look at these values, these are both 0. These are both -3. We call these symmetric points. And with symmetric points, the point in the middle, you'll always see this is the vertex. It's always surrounded by symmetric points. So that is a point that you always need to find when you are graphing. And you always got to graph that vertex first. So 0, 1, it needs to be graphed first. And then your symmetric points at 1, 0, and -1, 0, and -2, -3, and 2, -3. And we end up with the curve of a parabola. Oops. And so we end up with that curve. All right, let's look at the next one. All right, so let's use the points -2, -1, 0, 1, 2. All right, so we plug in -2, that gives us 4, plus 4 minus 3 gives us 5. 1 plus 2, which is 3. 3 minus 3 gives us 0. 0, 0, -3. Plug in 1. 1 squared minus 2, so -1 minus 3 gives us -4. Plug in 2, you get 4 minus 4, -3. So right there you can see the symmetric points. So that means if we plug the next one, it would be 3, 9 minus 6 minus 3 gives us 0. So you can see the symmetric points. Okay, so graph that 1, negative 4 first. And then plug the points around it, which is 0, negative 3, and 2, negative 3, and 3, 0, and negative 1, 0. So then we have our parabola that's opening upward. But again, always graph your vertex first. All right, let's look at another example. All right, this is an example of a cubic function, and we know that because it's x cubed. This is an example of an absolute value function because we can see the absolute value bars. So we know that because of the absolute value bars. All right, so with cubic, we graph it a lot like quadratic, where we use negative 2, negative 1, 0, 1, 2, and plug in negative 8 plus 1, negative 7. Plug in negative 1, that's 0. Plug in 0, you get 1. Plug in 1, you get 1 plus 1. Plug in 2, you get 8 plus 1, 9. All right, and then we plug that in. 0, 1, negative 1, 0, negative 2, negative 7, 1, 2, and 2, 9. Somewhere about there. And we get this graph that I always thought kind of looked like a lightning bolt. Okay, absolute value. We're going to use the same 5 points as we do with quadratic and cubic. Negative 2, negative 1, 0, 1, 2. So remember, it makes it positive. So 2 minus anything becomes positive. So 2 minus a negative 2 is 2 minus positive 2. So that's 0. 2 minus 1, 1. 2 minus 0 is a 2. 2 minus 1, 1. 2 minus 2, 0. And again, you can see the symmetric points here and here. So graph vertex first. Always graph your vertex first. So 0, 2, 1, 1, and negative 1, 1. Negative 2, 0, and 2, 0. So this one kind of looks like a V, but because it's a negative, it's an upside down V. All right, let's look at some more examples. All right, so this is the vertical line test. So I'll just go ahead and read it. If it is possible for a vertical line to cross a graph more than once, then the graph is not the graph of a function. So what we're going to do is we're going to draw vertical lines. So here, once, 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 that passes the vertical line test. This is a function. Here, touches twice. That fails the vertical line test. So this is not a function. Touches once, 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 once. Anywhere I draw it, it can only touch once. It passes. Yes, it is a function. Right here, touches twice. So not a function. Here, twice. Here, twice. Here, only once. But because anywhere it touches twice, that makes it a fail, not a function. And that one passes. Yes, is a function. All right, that's all I have for you today. Thank you for watching and happy studying.